This video is about multiple representation. So Mario starts out with a bag of 100 coins and collects a bag of 10 coins every minute. Identify the variables and write a dependency statement, then create a graphic, numeric, and algebraic representation of the situation. So in this case, we have that Mario is collecting coins, and then he gets 10 new coins every minute. So the thing that's happening when he's collecting is our independent variable. It's a thing we can't control. So our independent variable would be minutes. And our dependent variable is what's happening based on the minutes passed, which is the coins collected. So when we write a dependency statement, we would say coins collected depends on the number of minutes. Next, we're going to complete our numeric representation. So remember that Mario already has 100 coins, and then he's collecting 10 coins per minute. So we're going to do 10 coins times the number of minutes. So 10 times 10 is 100, plus 100 gets us 200 coins. After 20 minutes, we have 100 plus 10 times 20 minutes. 10 times 20 is 200, plus 100 is 300 coins. Then he has 100 coins, plus 10 times 30 minutes. 10 times 30 is 300, plus another 100 is 400 coins. Then we need to create an algebraic representation. So remember, we have two variables here. We have minutes, which we're going to use M for, and we have coins, which we're going to use C for. So we're trying to figure out how many coins he has, so that variable is going to be by itself. So C equals, Mario already had 100 coins, and then he's collecting 10 coins per minute. So we're multiplying 10 times every minute. In the graphic representation, we need to create a graph. So remember that your independent variable is going to go on the x-axis. So we have minutes on the x-axis. Remember that we were counting minutes by tens. So we're going to just do 10, 20, 30, 40. On the y-axis is going to be our dependent variable, which in this case is coins. Remember that the coins were going up by hundreds. So we're going to start at 100, 200, 300, 400, 500. Remember that you can't just start at 200 unless you make a little squiggle to show that you're skipping numbers. But because the numbers were kind of close together, I was able to just go up by hundreds. I didn't have to worry about that. So then I'm going to plot my points. So I know at 10 minutes he has 200 coins. At 20 minutes he has 300 coins. And at 30 minutes he has 400 coins. And I'm just going to connect my line all the way through and put an arrow on the one side. It also makes sense that my graph should start at 100 on the y-axis for the line because he started with 100 coins. And then I need a title for my graph, so I'm going to call this Mario's Coins. Papa John's has a special for $12 for a medium pizza plus $2.50 per topping. Identify the variables and write a dependency statement. Then create a graphic, numeric, and algebraic representation. So in this case, we're looking at two things. We're looking at ordering pizza and getting toppings on it. So toppings is going to be our independent variable. Our dependent variable, though it doesn't really say it in the problem, we know that we're buying pizza, so we have to pay for the pizza, so it's going to be cost. Another way to figure out our dependent variable is also to look at the table, and the column all the way to the right is cost, so that means this is our dependent variable. It's what we're trying to find. So our dependency statement then would be the cost of pizza depends on the number of toppings. So in this case, we know that the pizza costs $12 plus $2.50 per topping. So $2.50 times 2, which would get us $17, because $2.50 times 2 is $5, plus 12 is 17. Then we have 12 plus $2.50 times 4. 250 times 4 is $10, plus 12 gets us $22. And then we have $12 plus 250 times 6. 250 times 6 is $15, plus 12 would get us $27. So now we're going to complete our algebraic representation. So remember, we have two variables. We have T for toppings, and we have C for cost. So we're trying to find the cost. So cost equals the pizza cost $12 plus $2.50 plus $2.50 per topping. So now I'm going to create a graph again. So on the x-axis is my independent variable. So in this case, toppings. And remember from our table that the toppings went up by 2. So 2, 4, 6, 8, 10, just so I fill out that entire axis. And then I have cost. Now this is where we have to be careful. If we go back and look at our table, we had $17, $22, $27. We can't just start at $17. We need to figure out a number that we can go up by that will evenly space our graph. So I'm going to go up by 5s starting at 0. So I have 0, 5, 10, 15, 20, 25, 30. So now when I go to plot my points, I know that a pizza that was 2 toppings was $17. I'm just going to kind of estimate where that point goes. A pizza with four toppings cost $22, and a pizza with 6 toppings cost $27. We also know that the first pizza with 0 toppings cost $12. So we can also put that point on our graph, and we can connect our points and add an arrow. And the last thing we have to do is give our graph a name. So we're going to call it Papa John's Pizza Special.